the main part of the statistics problem, what they are given, how to computing the solution for the problems by using some test. But already I have shown some analysis tab, some type of test in JAMOVI environment. Today we are going to see detailedly about this types of tests we have to do, where we have to do the which test, and some we'll see some examples, data sets test. We will see some example problem. We will see today's sessions. Okay, let's say share the screen. My screen is visible, sir?
Yes, sir. Yes, sir. It's visible, sir.
Okay. Okay, so fine. So today we are going to see about the basic concepts of hypothesis testing. So before going to see the hypothesis testing, we should know that there are two types of testing in statistical analysis. We have paired test and paired test. So paired test, under the paired test, we are going to see about this basic concept of hypothesis testing. So already we know that the data statistics, we have classified the two types, the descriptive statistics and inferential statistics. Descriptive statistics is nothing but how to do the statistical analysis and computing on the entire data set. For example, if we are given, they are given the 100 records of data, means we should do that statistic analysis on the entire hundreds of data. That statistics is called it as descriptive statistics. So presenting, organizing, and summarizing the entire data, that is descriptive statistics, we have shown in the exploratory data analysis. We applied the exploratory data analysis on this descriptive exploration data statistics in JAMOVI. We have to calculate the mean, median, mode of the entire data sets what they are given, right? Second, today we are going to see about this topics, that is the second category of the statistics is inferential statistics. So here we have to take in the entire population. From the entire population, we have to take the sum of the samples. We have to apply the statistical analysis only that samples, and we have to give the solutions for the samples. We have to summarizing the data. We can give a solution for the sample the data set, which is similar to that all the data. So for this inferential statistics, our data should be normally distributed. Then only we will have to do that inferential statistics we will be see. Okay. So the major classification is two types: descriptive statistics and inferential statistics. Already in the descriptive statistics we have completed, that is exploratory data analysis. We have to apply the exploratory data analysis on the entire data sets what they are given, that is the descriptive statistics we have completed yesterday. So today we are going to see about the inferential statistics test. Everything will be see. That is, you have to do the statistics and computing only on the sample of data, not the entire data. So there is the definition. The descriptive statistics uses the data to provide description of the population or sample either through numerical calculation or a graph or tables. So yesterday we have seen in the exploratory data analysis. Inferential statistics is to make inferences and predictions about the population based on the sample of data taken from the population. There is the entire population. Yesterday we have seen the statistics. Inferential statistics makes inferences and predictions about a population based on the sample of data taken from the populations. Okay. See the diagram itself, we can see this here. The descriptive statistics describes the entire data, the yearly growth of some paddy or grass, something like that. So inferential statistics studies a sample of the sample, some same data, that is the samples. You have to take the samples and perform the analysis, statistical computing, that is inferential statistics. So for doing inferential statistics, we have to do that. Methods of inferential statistics is estimation of parameters and testing of statistical hypothesis. These are the main thing we have to do. for doing inferential statistics. See, we have to the entire population. From the entire population, we have to take some samples, that is representatives. Then we have to give them as solution to that the entire samples. So this is called it as inferential statistics. So what are the parameters and we have used in the statistics for the descriptive statistics, and then and that is in the in inferential statistics. A measure calculated from the population data is called as parameter. That is, parameter is nothing but that is comes under the term in the descriptive statistics. Sorry, different descriptive statistics. The measure calculated from the sample data is called as statistics. So parameter and statistics. Here, for descriptive statistics, the parameter of mean is represented as mu. The statistics here, mean is represented as x bar. So the symbol of difference varies for the two statistics computations. Here the standard deviation is represented as sigma. Here is S. Here the proportion is P, small p. Correlation coefficient is rho. Here R. Okay. So this is the symbols we are used for this central tendency of the statistics of descriptive statistics and inferential statistics: mean, standard deviation, proportion, and correlation coefficient. We can take these mean and variance, standard deviation, correlation coefficient. These are the values we can use for the testing the statistical values for computing the solution. The estimation, there are two ways of estimation here in the statistics: point estimation and interval estimation. The point estimation is, for example, we have to find out the median. Give them, we have hundreds of data. We want to conclude the median of this data. Means we have to take the average of the two values, the 50 and 51. We have to calculate the sum and average. It will give the solution directly. There is a point estimation. Then interval estimation means we have to take the samples of limit, that is quartile data, Q1, Q2, Q3. Last session we have done Q1, Q2, Q3. That interquartile range, we can apply the statistics on the interquartile ranges of estimation, that is called as estimation of population in the intervals, the lower confidence level and upper confidence level. That is between this lower confidence level with upper confidence, that is called as width of the confidential interval. So estimation is a process whereby we select a random sample from the population and use the sample statistics to estimate the population parameters. So we can take a points estimation. We have to take the median value. I can do the statistical computing. That is called as point estimation. We can take the intervals of data. For example, we have hundreds of records. I'm going to take from 25th percentile to 75th percentile of data. I have to apply the statistical computing on this only the ranges, this upper quartile range to lower quartile Q1 to Q3. That is called as interval estimation. The point estimation is a sample statistic used to estimate the exact value of the population parameter. That is, I can take only the sample size actually equal to parameter value is extremely small. So for this reason, point estimation is rarely used. So because taking only one sample, we can give the statistical analysis. This it does not give exact result. So instead of taking this, even if we can take in the interval estimate, we can be able to give it. So at least computed estimated probability result we can give. So point estimation, we can't exactly predict that whether the problems gives this result or not. Okay. So mostly we are not rarely using this point estimation. Next, interval estimate. This is called the confidence interval. So range value is defined by the confidence level within which the population parameters are estimated to fall. So the interval estimation is less precise, but it gives more confidence. So that's why we are saying it is a confidence interval. The interval estimation is also called as confidence interval. So next we are going to see about the testing, what we have to do apply for the statistical computing test, that is types of hypotheses. So there are two types of hypotheses. see that that's null hypothesis, that is statistical hypothesis is classified into null hypothesis and alternative hypothesis. Before that, we will see that what is hypothesis. Hypothesis is nothing but there is assumption. Okay, if you take any problem, I have to make an assumption of two assumptions, whether this is maybe happen or may not happen. For making a maybe happen, I said as it is a yes, it's happened. That is, I say it is a null hypothesis. It not happen, it will not happen. That is, that way I'm setting as alternative hypothesis. This is the assumption, yes, it is happen. That is, in versus it did not happen. So statistical hypothesis is an assumption or any logical statement about the parameter of the population. So, for example, patient suffering from chikungunya takes on an average more time to fully recover than the patient suffering from the dengue. So this is the statement. Maybe yes, it may happen. Chikungunya suffering patients may be recovered earlier than the dengue. It happened or it may not happen. So chikungunya does not, the patient suffering from the chikungunya will not recover rather than the dengue who are suffering from dengue. The average annual income of Indian farmer is 2018 is 78,000. Yes, it is 2019, or it does not sound, sorry, it is 78,000, it does not 78,000. So proportion of diabetic patients in Tamil Nadu is not more than 15%. Yes, it is more than 50%. It is my null hypothesis. No, it does not. It is not more than. It is less than 15%. It is the alternative hypothesis. So we should have a two hypothesis settings. Then by applying some tests, we can given the solution for whether our assumption is correct or not. Okay. First, we should say the assumption, both assumptions, one positive way and negative way. So positive way, I said the assumption is a hypothesis, that is a null hypothesis. The negative way hypothesis is we say it is the alternative hypothesis. Okay. The first one is null hypothesis. A null hypothesis is a general statement about the population parameter or about the relation between the two population parameters. It is denoted by the H0. That is, H hypothesis 0 is defined as null hypothesis. It's a parameter assumption specific value that is called as simple hypothesis. That is, if the parameter assumes specific value, for example, the mean, that is average value is 280. The proportion is 0.10. This it gives the exact value, means that null hypothesis types is called it as simple hypothesis. A null hypothesis, the parameter assumes set of values that is less than greater than. Here the mu value is greater than 280. So p value is less than 0. That is proportion value is less than 0.10. Mu is, that is mean, p is proportion, right? So this is composite hypothesis. If it is gives this values, the mu value and proportion value is greater than less than, it describes that as the range of values, set of values, that is called as composite hypothesis. Exact values means that is simple hypothesis. So that is first we have to set for any given problem. First we have to set the null hypothesis. It's the first step. Second step is we have to set this alternative hypothesis. It will not happen or it will not happen. So alternative hypothesis, a statistical hypothesis which is complementary to the null hypothesis. That is inverse to the null hypothesis. It is called as alternative hypothesis. So null hypothesis denoted by H0, the alternative hypothesis denoted by H1. So null hypothesis as here mu equal to mu naught. I have to set the variable values mu equal to mu naught. That is mean equal to mean value. So I am here alternative hypothesis. I said it is a not equal. Okay, mu not equal to mu naught. If it is, if you take an exact value, that is we have to apply the two-tailed test. Okay, we will see the test details. I just give an intro about what is this. Two-tailed test. If it is mu not equal to mu naught, means we have to give the two-tailed test. We will see the sample of data sets. We will apply and we will understand how we will do the test on this sub data sets under some given problems. Okay. If mu greater than mu naught means we have to do that right side one-tailed test. Mu less than mu naught is left side one-tailed test. Okay. So what is this hypothesis what we are setting, that is mu equal to mu naught. Alternative hypothesis is this mu not equal to mu naught. It happen, does not happen. That is. That is this term we should understand, hypothesis and null hypothesis. So next we have to go for the testing of hypothesis. How we are going to test this hypothesis? Whether yes, my assumption is correct, my assumption is not correct. I can accept the hypothesis, I reject the hypothesis. This is the two we should follow for any given problem as a research work. We'll give the solutions. So as a researchers, we should analyze the problem and apply this hypothesis testings and statistical testings. Then we will give the solutions. Yes, my assumption is correct, my assumption is incorrect. This is the term we should follow in this hypothesis testing. This is the problem. The procedure to decide whether I accept or reject the null hypothesis called as testing of hypothesis. Next here, then that is the important value, that is we say it is a p value. By this p value, we will conclude our assumption is right or not. Generally, in the statistical, the descriptive inferential statistics, the p value is should be 0.05. Okay, I'll show you 0.05. If your the p value you have calculated for any testing, if it is less than 0.05, you have to reject the hypothesis. If it is greater than means you should accept the hypothesis. That is null hypothesis. We will see one by one. So p value is nothing but it is the probability value. P is nothing but probability. Probability value of an observed data, observed result, assuming that the null hypothesis is true. Okay. If null hypothesis is true means that is the p value is greater than 0.05. So here we take in as the term as 0.05. We know that probability value should be present between 0 to 1. Why I'm taking 0 to 0.5? That is here in this inferential statistics. So we can take this p value should be a 0.05. Okay. So see this diagram, the p value as this is very unlikely observations, the left sides, though it should be your, if you are seeing the p values, your data, entire data should be normally distributed. Your data is what is not only the entire data, what are the, even if the sample data you can take means even that sample data is also should be a normally distributed data set. So we have to check the normality of this data, what they are given for this solution problem, computing the solutions. Okay. So the p-value is the probability. The test statistics would take value as extreme or more extreme. It should be greater than 0.05 than the observed test statistics, where H0 is true. H0 is true means your null hypothesis will be true. You have to accept the hypothesis. If it is not false, means you have to reject the hypothesis. That is, alternative hypothesis will be false. Okay. So for right-tailed hypothesis, this is the right-tailed hypothesis. Here P equal to P of T greater than T, greater than or equal to T. Here H0 is 2. For left side hypothesis, P equal to T of T less than or equal to T, H0 is true. So for two-tailed hypothesis, it will be a 2 parameters. We have to check with 2 parameters. Means your p-value is 2 into minimum of left hypothesis, left tailed hypothesis and right tailed hypothesis. Okay. See, for typical analysis, using the standard of, we have to use this alpha, that is 0.05. That is the standard deviation value. The alpha is 0.05. Curtain. The null hypothesis is cut off. The null hypothesis is rejected when the p less than or equal to 0.05. Whenever we doing any statistical test, we can calculate the p value. So here no need to do any calculation. We simply apply the test. The p value is automatically generated by the code we already written in R programming at the back end of JAMOVI. Here no need of calculation, nothing and all. You simply tick, tick, tick. Should understand for which problem, for what are the tests you have to apply. That is, so rejected. This is the for typical analysis using the standard of alpha equal to 0.05 cut off. The null hypothesis is rejected. FO, when the null hypothesis is rejected when p less than or equal to 0.05. When it will be accepted, that is not rejected means your p should be greater than 0.5. That's why I said the p value should be more and more extreme than the observed test statistics. When hypothesis H is equal to true. So it is rejected when p less than or equal to 0.05. It is not rejected when p greater than 0.5. This is the main thing we should give the we should understand for doing any problem problematic computing what they are given in the statistics. We can give the solution for our research works based on your research works. Okay. So types of testing, sorry, steps of testing of hypothesis. So what are the steps you have to follow for doing hypothesis testing? First one, setting up the null hypothesis. First, you said that the given problem is there. For example, I say some example. The patients of who is suffering from chikungunya recover more than the patients who are suffering from dengue. Yes, I say it is true. Yes, they are recovered earlier than the dengue people. So, for example, those who are suffering from the chikungunya, they are taking the recovery 2 weeks. Means for dengue, it may take 4 weeks. Means, yeah, it's true. I said like this, yeah, my assumption is correct. Maybe my assumption is correct. That's why I said my null hypothesis is true. Second one, step two, setting up of alternative hypothesis. I said, no, the people of chikungunya who is suffering from chikungunya, they are not recovering than the people who are suffering by what is that dengue. So these are that. First, you have to set the hypothesis. That is H0 value you have to set, then H1 value you have to set. So next, the third step is check the assumption of the test. That is, we have to check normality of the test, whether the data is normally distributed or not. Next, we have to determine the test statistics and p-value. So we have to determine what is the test we are going to apply for this data sets values and how we have to calculate the p-values. So from the p-value, we can come under the conclusion of the step 5. If the p-value is less than level of significance, that is level of significance is 0.05, we reject the null hypothesis. Okay, that is at the time if I am getting the p-value is less than 0.05 value means for the people who are suffering from the chikungunya recover than the people who are suffering from the dengue, I am getting 0.01 means it is very less than 0.05. That's why I reject the hypothesis. But that is the term I go with the alternative hypothesis. Okay, if the p-value is greater than the 0.05, that is the gamma equal to 0. Alpha equal to 0.05 equal means we have to fail to reject the hypothesis. That is, I accept the hypothesis. I have accepted the alternative hypothesis. We failed to reject the null hypothesis. Okay. Sorry, we accept the null hypothesis. Okay. So this is the steps we have to follow for the testing of hypothesis. The first step is setting up of the null hypothesis. Second step is setting up of alternative hypothesis. Then check the assumption of the test. So determine the test statistics of and p-value. And finally come with the conclusion. So some of the tests we can do. These are the testing we can do in statistics. Testing a single mean. Testing the significant difference between the two means. Mu0, we have taken two parameters. For example, blood glucose level of the male, blood glucose of the female. So blood glucose level of the male is one parameter. We have to calculate the one mean blood glucose level of the female. That is the second parameter. The mean is the mu1 and mu2. Testing a single proportion. Testing single difference between the two proportions. Testing the single standard deviation. Testing the two standard deviation. Testing the mean for two or more than samples. Two or more than samples. Three parameters you have to take. Okay, like for example, I can take in the transgenders also. Okay, that is testing the standard deviation for more than two samples, testing the proportion for more than two samples, testing for non-normal population, testing correlation and regression coefficients. So these are the some tests we can do on statistical testing hypothesis testing. So designing of test, how we can design the test based on your data on mean, median, and parameters, how many number of samples you can take for the test, whether it is a one sample or two sample or more than two samples. Okay, first I have to take the scalar value. It means a normality assumption. Normality assumption means my data should be normally distributed. That is, see here, this p-value. See this diagram, this distribution of this density graph, probability density graph it shows. Our data is neither the entire data or a sample data. It is normally distributed. Okay, that is the main thing we should follow. So whether my scalar value means a normally assumption, if I'm taking the parameter as a mean for checking my testing the hypothesis, if I take a one sample, that is, I said hypothesis, null alternative hypothesis. That is null hypothesis mu equal to mu naught. Alternative hypothesis is mu equal to mu not equal to mu naught. I go with one sample t test because I have taken one sample parameter, only one attribute values for testing the mean value. I go with the test name is called as one sample t test. Okay, I will share this slide PPTs for the future reference. You can use this slides for designing the test. Okay, currently you cannot mug up and remembering all these things. Okay, you should repeat at least study and do the practices on this samples of data sets. Then only we can understand for which problem, for which data sets, for which scalar values and parameters, which is the test we are going to do. Okay. All the tests are available in JAMOVI. We simply take that one sample t test that it will be applied. Okay. We can't do that steps of execution. We can't do the first test. Two test samples. So new one is a sample one mean, new two is a sample two mean. Okay. For hypothesis H0, and there is null hypothesis. HA is alternative hypothesis. Mu one not equal to mu two. That is two sample t test. Then test greater than two samples. So test mu1, mu2, mu3 up to mu k, that is mu n number of parameters you can take for your testing. If these parameters are dependent, you need to do that statistical analytic computing. You need more than two values for your testing means you should take this three parameters. At least one mean difference, you go with analysis of variance test. Okay, we'll see this analysis of variance in afternoon, ANOVA. Okay. So if you take a mean as a parameter, if it is only one sample, you can go with one sample test. If it is two samples, you can go with two sample test. If it is more than two samples, you go with analysis of variance. Next, if you take a parameter as a standard deviation, okay, then if it is your data is scalar data, it is normally distributed. Then if you take one sample means you can go with psi square test. Okay. If it is two samples, you can go with F test. If it is greater than two samples, you can go with Bartlett's test. Bartlett's test. Okay. Then your data is scalar, but it is not normally distributed. You're taking the parameter as a median. The median is a parameter. I already told the test that point investigation, that is the median. I said we are not rarely we have used this as statistical test for computing that analysis. Because we can by using the single median point we can't decide this entire assumption. Okay. So here for this we can do the Wilson's test, then Mann-Whitney's test for the two samples, then Kruskal-Waltz test for the more than two samples. Whether your data is not normally distributed, they are taking the data as scalar data. Next, the third one is categorical data. We have two types of data, scalar data and category data. That is a nominal and ordinal, and scalar values, that is a continuous values. Already we saw in the last exploratory data analysis, right? So proportion values, that is, here it is for test for one proportion, that is one sample. Test for two proportion for the two samples. The binomial analysis of means for more than two samples. Okay. So this is the way we have to decide our test. For which data, for which parameter, for which samples, for which test we have to apply. Where it is a scale and mean, scale, a normally distributed and standard deviation. Scale, non-normal, it is a median. So categorical proportions. So for which data sets, for which data, for which type of parameter, for which type of how many number of samples, we can decide in our test. So t test for single mean. If I am taking a single mean, only one mean value, I can go with these steps. What are the steps I have to follow? So first, if it is a null hypothesis, first I have to set the null hypothesis. Yes, the given problem is correct. If the given assumption is correct, I said mu equal to mu naught. My assumption is correct. Next, alternative hypothesis, I said mu not equal to mu naught. So null hypothesis is defined by the value the tick and h is 0. Alternative hypothesis is defined by the variable values h1. Okay. Then I have to check for the assumption, that is a normality distributions. The population from which the sample drawn is assumed as a normal distribution. For check the normality, I'll go with Shapiro-Wilks test or QQ plot. By using this graph, the test, I can decide whether my sample data or my entire data is normally distributed or not. Okay, it should be. If you go with the statistical analysis of the samples, whether sugar data is normally distributed. Next, you can apply the test statistics, that is t value. You have to getting the t value and the p value. After that, by this p value, then only you can go with conclusion. Whether the p value is less than or equal to 0.05, you have to reject the null hypothesis. Less than 0.05, that is level of significance here, this for the general statistics terms is 0.05. If the p value is greater than level of significance, means we fail to reject the null hypothesis. Okay. So let's t-test for single mean. So we have a sample example. We'll see more and more example for each test. We will the forenoon session we will have this. The examples. For example, the example one. Just read the example. Based on the field experiments, a new variety of green gram is expected to give an average yield of 12.0 quintals per hectare. So what is the problem they have to set? Based on the field experiments, a new variety of green gram is expected to give an average yield of 12.0 quintals per hectare. Okay, the productivity of this green gram will be 12.0 productivity per hectare. So variety was tested on 10 randomly selected farmers fields. So they have to select the 10 randomly selected farmers fields. The yield were recorded as per hectare per quintals, recorded as for the farmer 1, 14.3, 12.6, 13.7, 10.9, 13.7, 12.0, 11.4, 12.0, 12.6, 13.1. Do the results confirm the expectation? Yeah, whether based on the field experiments, a new variety of green gram is expected to give an average yield of 12.0. What does mean average? That is a mean. Mean value they have to give 12.0. Yes, this new green gram gives 12.0 quintals per hectare. That is my null hypothesis. It does not give 12.0. It gives less than 12.0. Means my alternative hypothesis. First, I have to do first step. My assumption is correct. Yes, for the given problem. The new variety of green gram is expected to give average of 12.0 quintals per hectare. This is my H is 0. That is mu equal to 12. My alternative hypothesis, I said, no, mu not equal to 12. It may be greater or it may be lesser. Okay. So for this data sets, already they give the data set green gram Excel SLC. I'll show the examples. I'll demonstrate how we have to apply find out the solution for the given problem. Okay. So first, I have to do the steps. Null and alternative hypothesis we have to set. So first statement is null hypothesis means, yes, my average yield is 12 quintals per hectare. I set H0 equal to mu equal to 12. My alternative hypothesis H1 equal to mu not equal to 12. That is, average yield is not 12 quintals per hectare. Okay. So we will go with the t-test for the analysis. So first we have to open, I'll demonstrate. Before that, I'll just give you a brief about this process. Now we are going to do the normality check. Before finding the p-value, we have to check the normality of the data sets, what the entire data or the sample data. So for that, we have to do the test name is called it is what? Shapiro-Wilks QQ plots. These are the two tests we have to do that. So first to open, I open my data set. That is green gram data set on my JAMOVI. Next, I go with the analysis. Go to the analysis and click the t-test. Here, we have only one attribute, that is yield. That's why we have to apply one sample t-test. Okay. Next, to select this yield and as a variable. Then the variable is drag and drop these variables to the variable value. Then we have to apply the central tendency. We can calculate mean, median, everything. The next, we have to check the normality is by clicking this Shapiro width. That is the normality checking we have to do with Shapiro width. Then here we have to check that the normality Shapiro width should be given the p-value. So p-value is, we have to check the p is value, it's given 0.89. It is greater than 0.05. The yield of green gram is normally distributed. Okay. If it is greater than 0.05 means your data is normally distributed, or else it is not normally distributed. Here also we have to take this data value as this 0.05. That is Shapiro width. Next, second one is QQ plot. So it's a plot will be there. Yesterday we saw that. So here we are defining the QQ plot. We just pick the QQ plot. It will generate this graph on your JAMOVI. Here all the points are closely related near to this linear line. That is the diagonal line. So here the points are almost close to the line. So we can say this yield of green gram is normally distributed. By the graph itself, we can say. So most of the lines are in this, the diagonal line. That's a linear way. That is, we say it is a normally distributed. Next, we have to apply to go with one sample t-test because we are taking the only one sample, that is a yield. When you click on the test, you can apply the one sample t-test. Then you can drag and drop this yield here, the dependent variable. Then apply the test value. That is, here the test value is 12 because your mean value is 12. Okay, right? Mean is 12. So you have to enter the t value is 12. Then test t value not equal to test value greater than test value. Then it will give that the test name is student's test. The test name is the one sample t-test is called it as student's test, student's t-test. So it will give the value of statistic value 1.84. The p value is 0.100. So here the test statistics t value gives 1.84 and p is 0.100. So 0.100 is greater than 0.05. That's why we have to fail to reject the null hypothesis. That is, our assumption is, the first assumption is null hypothesis is true. Okay. That's why we have to accept the null hypothesis of the 5% level of significance. Now we have come to the solution. It comes come for the solution. A new variety of green gram is expected to give a yield of 12.0 quintals per hectare. Okay. So we'll demonstrate how we can do this. We'll open JAMOVI. Take some minutes.
Sir, your voice is not audible, sir.
Okay, sir. Okay, sir. Okay, sir. Once again, sorry. I muted. Once again, repeat everything. So first you have to open the data set, data field. I open the data, the test greengram data sets. I open it has the 10 data records of the greengram field that is taken from the 10 different farmers field. Okay. The question is as whether this greengram yield is a new greengram is given a yield of 12 per average. Okay, average is it gives us a 12. So first step, we know that null hypothesis is mu equal to 12. That is set the first null hypothesis. Yes, it is gives the average yield is 12 quintals per hectare. Second, I have to step to alternative hypothesis. I said the average yield is not given 12 quintals per hectare. Okay. So third steps you have to do that. What is that? You have to check the normality test. For normality test, you can go with JAMOVI. You open the data, then go with analysis, and then click exploration. You just click the descriptives. Here, you have to get the mean, median, mode, sum, whatever things you want. Everything will be generated. Before that, you should drag and drop this yield to the variables. Then it will calculate. It will show all the descriptive values. Now, the third step I said you have to check the normality. So Sharpe Wilk normality test you have to give. While I'm clicking the normality Sharpe Wilk, it will it is than 0.05. If it is greater than 0.05 means our sample data is normally distributed. The third point is, and the third step is over. And one more test for checking the normality, we can go with the plots. That is QQ plot. While generating the QQ plot, it will generate the linear of linear. If it is a linear, means your data is normally distributed. So you see here, will generate the graph. So all the points are near to the linear line. That we can come that our data is our sample data, the 10 records of data is normally distributed. Okay. So third step is over. Next we will go for doing the test. Here we can take only the one sample, that is yield of green gram. Okay, only the one sample. That's why I can go with click with the test. It is independent sample, it is not a paired sample. We can go with only one sample. That's why we have go with the test name is one sample t test. I just click the one sample t test. I have the variable values yield. I just move this variable, dependent variable yield. Here, what is the test value? I have to check 12. What is they are given? That is whether they give a green gram value is given as 12. Either it is gives to 12. You just entered. So already we have done that normality test. 0.891 p-value is greater than normally distributed. So QQ plot, it will generate the QQ plot. Okay. From these values of this t-test, this t-test names is called as student t-test. The one sample t-test called it student t-test. So it gives the value as p equal to 0.100. The p-value is the proportion value is 0.100. It is greater than 0.05. That is, if it is greater than 0.05 means what? Your null hypothesis is true. You have to accept the null hypothesis. Okay, you reject the alternative hypothesis. That is, the new green gram yield will give the average value of 12 per 12 quintal per hectare. Okay, so this is normally distributed because p value is 0.891 for the Statistical t-test. And this p-value of one sample t-test gives 0.100. It is also greater than 0.05. That's why. So we say that so it is greater than p-value is 0.891. It is greater than 0.1. Yield of green gram is normally distributed. Then we apply the t-test. So I give the test value is 12. So now the new variety of green gram is expected to give yield of 12.0 quintals per hectare. Okay. So this is the way we have to do that hypothesis testing. Okay, next we have go with second example. We'll see. A researcher is investigating hemoglobin levels of schoolgirls in a particular area. 15 schools were randomly selected and their hemoglobin level is as follows. Does the data reveal the average hemoglobin level among schoolgirls is more than 11.5? That is, average hemoglobin level of among schoolgirls is more than 11.5. This is our hypothesis. So I said, yes, this is more than 11.5. The average hemoglobin level, that is mu equal to 11.5. I said the null hypothesis is equal to mu 11.5. Use 5% level of significance. So we will check. They're giving this 15 schools of student average levels of girls hemoglobin levels. Okay. So first step is we have to set the null hypothesis is mu equal to 11.5. That is, average hemoglobin level is not more than 11.5. That is, second alternative hypothesis is average hemoglobin level is more than 11.5. Okay. We have two hypotheses. We have set the hypothesis. Next, we have to check for this normality. We will do the test and we will decide whether it is normally distributed, whether it is we have to accept the hypothesis or not hypothesis. We will see by using the test. Now we open the JAMOVI, open the data. That is hemoglobin levels of girls. This is the data set. So first step is we have to check the normality. Third step, for that you have to click exploration, click descriptives. Then you have to take this HP. This is the variable you have to check. Then we'll go with checking this Scorpio with normality test. It is 0.505, which is greater than 0.05. That is, your data is normally distributed. Then also we have to, by using qplot also, we can decide whether the data is normally distributed, qplots. That is, here also most of these points are near to the line. That's why we said this is data is normally distributed. Okay. Then we'll go with test. So we have only one sample, that is hemoglobin levels of the girls. That's why I'm going to test the one sample t-test. I just remove these variable values. What they're asking whether it is more than 11.5. So I have to check the test values. More than 11.5. You can give this one. Here the test values, what is that? More than 11.5. Also check the normality test. So what is the p-value what we are getting for the student t-test? Can get the p-value is 0.893. The 0.893 which is greater than 0.05. So the next is p-value is also found that is normally distributed. There is 0.893 which is greater than 0.03. So we failed to reject the null hypothesis. That is, we accept the null hypothesis. That is, the average hemoglobin levels of the school girls is not more than 11.5. We said this average hemoglobin levels is not more than 11.5. This is our hypothesis. That is, we failed to reject the hypothesis means we accept this hypothesis, null hypothesis. We conclude that we have come to the conclusion. Okay. So this is the second example. Next, t-test for two independent variables. If we have two variables, these in the last example we have assigned only the one variable values. What is that? The first one is the yield of gram, yield, the next is hemoglobin. Here, if we go with two variables, means how we have to do the testing. So first step is get set the null hypothesis mu1 equal to mu2. Mu1 is the mean value of the first variable, mu2 is second variable. Then alternative hypothesis mu1 not equal to mu2 or mu1 less than mu2 or mu1 less than or greater than that. Here also for normality, third step is checking the assumption that is normality, Shapiro with QQ plot. Two population variants are unknown. Okay, that is, first we have to check the variance of the two independent variables. We have to check that whether it is equal, means we can go with AEIF test. Okay, the two samples are independently distributed. We can't do any test. Step 4 is we have to test the statistics and of the t and p value. From the p value, we can give the conclusion whether we have to reject the null hypothesis or fail to reject the null hypothesis. So for the t-test for equal variance, t-test for unequal variance. If it is unequal variance, we'll check Bell t-test. We have to do that Bell t-test. Okay, this is the test we have to apply. This is a formula for the t-test. So t-test for means of two independent samples. So I have the example. In a fertilizer trial, the grain yield of paddy, okay, that is per plot given the given kilogram, paddy is a kilogram, was observed as follows. So under ammonium chloride, it gives the 42 kilogram per plot, 39, 38, 43, 41 is the sample. Under urea, the paddy gives the yield as 38, 42, 56, 64, 68, 69, 62 kilogram per plot. The question is find whether there is any difference between the source of nitrogen. If the both ammonium chloride and urea they have a nitrogen, is there any difference between source of nitrogen of the yield of paddy? So for this here we have two variables, that is two samples. One is ammonium chloride, second one is urea. So based on this, we have to find the mean for each one, mu1, mu2. mu1 is average of ammonium chloride yield, average of under urea yield of paddy. Okay, first I have to check the hypothesis mu1 equal to mu2. There is no significant difference between the source of nitrogen, that is mu1 equal to mu2. I said the null hypothesis is alternative hypothesis mu1 not equal to mu2, that is there is no significant difference between the source of nitrogen. Sorry, this is there is a significant difference between the source of nitrogen. Here there is a mistake. Okay, significant difference. So first we have to do the normality check of for ammonium chloride and urea, whether it is both are greater than 0.05. That's why we conclude that it is normally distributed. By after the QQ plot you have to draw. Then you have to go with the test name is homogeneity of variance test. That is because it has a two sample test. The test is homogeneity of variance test. We get the value, p value is 0.014. Here the p value is 0.015. It is a less than 0.05. So what we have to reject the null hypothesis, that is variance are negative, not equal. That's why we have to set I have to use the t-test for unequal variances, that is Belk test. Okay, so we go with Belk test because the variance is not equal. Okay, that's we go with Belk test. The homogeneities of variance and test is far useful to check whether the variants are equal or not equal. Okay, that's why we go with homogeneity of variance test. Here we have to check the variances are not equal. That's why we go with Belk test. So instead of student t-test for the simple sample t-test, here I go with Wells t-test. Check the value of 0.012. This is less than 0.05. That is, we reject the null hypothesis. So there is a difference in the yield of paddy because of source of nitrogen. We can't prove the solution. We will see this demonstration. I just open this data set. Already have this. Fertilizers. Fertilization, fertilizers dot XML. Yes, correct. This is the data set, right? Correct. So this one represents this ammonium chloride, two represents this urea. Okay. So this is the yield. So yield is, we have to check it is a continuous variable, right? Fertilizers category is one is ammonia, second one is urea. Okay. I change the data variables. Now I have to go with descriptive statistics. I have to check the normality of this sample data. I just move this yield split by fertilizers. I have to go with checking the normality, scatiovic. So scatiovic of p values both are greater than 0.05. There's 0.75 for 0.172. The urea and ammonia both are ammonium chloride, which is one is ammonium chloride, two is urea. So both are greater than 0.05. That is, I say it is a normally distributed. The second test, we can go with QQ plot. You'll see the diagram, and from the diagram we can decide. So most is all these points are near to the line. Here also most of the points are near to the line. That's why we said, so our data is normally distributed. Second one is we have to test that homogeneity of this test, that is parity sample t test. So before that, you just know the value. You go with independent samples because these samples are independent, right? So just move this putting variable is fertilizer. First, you have to do that. I say in this slide for checking that homogeneity test for testing the variance of two samples, whether it is both variants are equal or not equal. If it is not or not equal means you can go with Welch's test. Okay. So you just go with homogeneity test. So it will generate the value of 0.014. So 0.014 is less than 0.05. That's why we have to reject the null hypothesis. That is, the variants are not equal. So we have to go for the t-test results, unequal variances, Wilks test. So now you have to do the test, called it as Wilks test for this yield of fertilizer. So just to click the Wilks test. So it will be appear next to the student's test. So generate the value 0.012, which is less than 0.05. It's here, the p value is less than 0.05. That's why we have to reject the null hypothesis. Wilks test values will be appears 0.012. So here we reject the null hypothesis. So there is a difference in the yield of paddy because of source of nitrogen we have to conclude. Okay. So this is the way we have to apply this testing and analyze this data sets and the problem, and we have to computing the solution. So there is this example: researchers wish to know the body temperature of the male is less than that of the females. So he took random samples of 51 females and 49 males, measured their body temperature. Here are also two independent variables. So what does the researchers to conclude? That is temperature of male and female also have been given. Now to set that mu1, mu2, that is null hypothesis mu1 equal to 2, alternative hypothesis mu1 less than mu2. Then you have to check the normality. The p-value is greater than 0.05 for both male and female. At QQ plot is also normally distributed. So the next we have to go for the test independent sample t-test. The independent sample t, because the two independent variables for male and female, that's why we go with for the temperature. We'll check this homogeneity of the variant test. It is greater than 0.05, that is variance are equal. Then we have to go with student's test. We'll check the value of 0.089. We got the p-values. It is greater than 0.05. So the body temperature of male is not less than that of female, because we have to failure to reject the null hypothesis. We have to accept the null hypothesis. So now here the null hypothesis is what? Body temperature of male is not less than that of the females. Okay, we will do that demonstration. After this, we will end up the session. I just to open. Body temperature. Body temperature at T. So I don't have the data set. So I'll find and share. So this is the steps we have to follow. This is the way we have to conclude the analysis. And we will by we are getting 0.089. It is greater than 0.089 is greater than 0.05. That is, we have to fail to reject our hypothesis. The body temperature of males is not less than that of the females. The next is t-test for the parity test. So same, we have to set the null hypothesis, alternative hypothesis, check the assumptions. The t-test for the t-set p-value. From this, we have to conclude the solutions. So there is a fruits, and before applying and after applying of the yard, that is farmyard manure, was observed the iron content of the fruits before and after applying farmyard manure was observed as follows: the fruit number and before applying, after applying. The data sets we have given. Is there any significant difference between the mean iron content of the fruits after applying the farmyard manure? Okay. Next, we have before and after. There is a data set we have. First, we have to set the null hypothesis B equal to 0. There is no significant difference between the mean iron content after applying the iron on the farmyard manure. Next, we have to set the alternative hypothesis. Then we have to check the normality. P equal to 0.536, which is greater than 0.05. That is normally distributed. PQ plot is also normally distributed. Then we have to go with paired sample t-test. Because we have paired samples after and before. Okay, this sample is called as paired samples. So you drag and drop this after and before. Then you have to check this measure equal 1 not equal to measure 2. So go with, because normally distributed, that's why I got to go with students test 0.529. It is greater than 0.05. We have to accept the null hypothesis. That is, you have to fail to reject the hypothesis. There is no significant difference between the mean iron content of the fruits after applying. So we'll see this demo. Fruit iron content. We have to check this. What is that normality of this? variables before and after go with normality Sharpe oblique. So both of 0.863, 0.083, both are greater than 0.05. That is normally distributed. Therefore, also you can go with QQ plot. You can check the QQ plots. This is also both are mostly all the lines are near to this line, all the points. That is normally distributed. Okay. Next, you can click with it is paired sample t-test because it is a before and after paired variables before and after. I just drag and drop before and after. So measure 1 not equal to measure 2. So first you have to check the normal t-test. Zero point 0.05. There is a no significant difference. You have to fail to reject the null hypothesis. That is, we accept the first one, mu equal to mu naught. That is D. There is no significant difference between the mean iron contents in the fruits after applying the form menu. Okay. So this is the way we got to do the hypothesis testing for sample t-tests. So this is the t-test we have done. So after this, the phone session is over. If you have any queries, please ask me.
Thank you, Thomas sir, for your insightful presentation. Now it's time for Q&A. Dear participants, please raise your hands for unmute or kindly post your questions in Q&A section or chat box. The Commissioner sir is eager to address your questions and provide further clarification. Dear participants, kindly post your questions in Q&A session or chat box. Dear participants, if you have any questions, you can post it in chat box or you raise your hands. I will unmute you. So thank you, Kami sir. I extend my heartfelt thanks to our management for providing this opportunity. And my special thanks to our speaker, Kamiswaran sir, for sharing his valuable insight. Last but not least, I thank all the participants for their active engagement. Once again, I thank you all. Thank you, sir.
Thank you, sir. Thank you.
Please note that session 5 will resume today at 2:30 p.m. So feedback link has been posted in the chat box. Please submit your feedback by 1:15 today. Thank you, sir.
Thank you, sir.